Hello, students of Seneca. Welcome to another session. Today we are getting a bit basic. We're looking at the pH scale. It's a very important topic. Hopefully, you can go through it, clear some stuff up, and provide a really good revision session for everyone. So let's get started. pH scale, it runs from a scale of 0 to 14. And basically, it tells us how acid or how alkaline something is. And you might hear me say base or basic, and base and basic is the same as alkaline. pH of 7 is exactly neutral, and as the pH gets lower, we make acids, and as the pH gets higher, we're in alkaline territory. So really strong acids, they're going to have a pH of 1. That's going to be something like hydrochloric acid. Vinegar, which you'll put on your chips, that'll be like a pH of 3. And then as we go to alkaline, around a pH of 9, that's your washing up liquids. And then sodium hydroxide, super strong base, that's going to be pH 14, and it produces OH minus ions, whereas an acid produces H plus. So again, other places where we find acid could be in nature, so acid rain. Neutral stuff is pure water, and alkaline, washing up liquids. And just to recap, key thing is acids, they form H plus ions. You may also hear those called protons. An H plus ion and a proton, exactly the same thing. Whereas alkalis form hydroxide ions when dissolved in water. So how do we measure pH? And there are two main ways. The first is using universal indicator. And that's like all the colors of the rainbow. It starts all the way at red for an acid, and then we go to like orange, yellow, and then green. Green is pure neutral, and then we go down to like blues and purples up to pH 14, and that's going to be the alkalis. We can also use a pH probe that will give us a numerical value. If we're in a lab, that's going to be a much more accurate measure. So something I've seen on an exam sometimes is an experiment will use indicator to measure the pH, and one of the questions will be suggest a way that the accuracy of the experiment could be improved. This is where the pH probe comes in. It's much more accurate than using indicator, because indicator you're using your own judgment to match up the color with the pH. So pH probe, super accurate. So good thing to remember. And so let's recap. Universal indicator, that indicates the pH through colors, whereas a probe, that will give us a numerical value.
The pH scale is a measure of acidity.
Now, the pH scale, what does the pH even stand for, right? pH actually stands for potential hydrogen. So do you remember what produces H plus ions in solution? It's an acid. So acids produce pH ions. So by measuring the concentration of H plus, that gives us the pH. So at a pH of 0, the concentration of H plus ions is 1 mole per decimeter cubed. So that's going to be really, really acidic. And then as we go to a pH of 1, the concentration of H plus ions is 0.1 mole dem. So every time the concentration of H plus decreases by 10, the pH goes up by 1, okay? So that's a really handy ratio to remember. So if we had a pH of 2, for example, we would just divide by 10 again, so the concentration of H plus would be 0.01. So that's the key thing to remember. Concentration of H plus
Universal
tells us the pH. Okay. So two important facts about acids. They form H plus ions when dissolved in water, and the pH is less than 7, not more than 7. What's more than 7? An alkali. Perfect. Now, do we remember the two ways to measure pH? We've got our probe, and we have our universal indicator. Those are the two. Which one is more accurate? It's the pH probe. Okay, so for this pH scale, concentration of H plus ions is what the pH scale measures. If we have 0.01, remember we start at 1 mole dem. If we go to 0.1, it's a pH of 1. 0.01 is a pH of 2. And if we go all the way to the other end of the spectrum, do people have an idea what 1 times 10 to the minus 13 mole dem would give a pH of? It's going to be 13. What's quite nice as we get to the bigger numbers, like 1 time, well, the smaller numbers, but with the bigger minus 13, we can just use the power to tell us the pH. So 1 times 10 to the minus 9 is a concentration of H plus, gives us a pH of 9. Okay, so we've done acids. Let's talk about alkalis. Alkali has a pH of greater than 7. And remember which ion they form in solution? OH minus. And when we want to measure pH, we use universal indicator. And there are other indicators like phenolphthalein, methyl orange, and litmus paper, but they can tell us about a change in pH, but we don't use them to measure pH and give like a numerical value. Okay. So that is everything I wanted to talk about the pH scale. I hope everything made sense. Make sure you leave a comment, leave a review, let us know what you think. Hope it was a useful run through, and be sure to find your chemistry module on the Seneca website, consolidate it, click through the unit, and go through the questions to help consolidate your knowledge. And I'll see you on the next one. Thanks very much.